Hi everybody. This is more of an addendum to Bernie's explanation and samples based on his challenge about why this particular sample code won't work. And I thought some people may be looking at code in, in an email where you have to read it. Maybe that's a little more difficult than listening to somebody talk to you about it. So if you can stand listening to me, then you might get by with this. So first let's look at this get pointer function. That is the one that is not working the way we would like it to, because as Bertie demonstrated, when you call do something else, all of a sudden you can't print the value of that pointer. Well, why is that? Well, to put it simply, it's because we've received the address in P of a variable for which no longer exists, or for which the system has been given the right to overwrite. So let's look at this function getLocalPointer a little closely. We declare a local variable called b and assign a value to it of 6, and then we return to the caller the address of b. Well, the address of b, that exists and is valid for as long as getPointer, long as that function is active. After that returns, after a call returns from that function, b is no longer valid, or it can't be counted on to be valid, because memory could move for various reasons or get reused. It's then marked for reuse. So b could become invalid, even though in one of Bernie's examples there, he specifically put together an example where memory didn't move, so therefore you could print the value of p. But so you can't depend on b in this particular situation, because again, when a function's called, all the variables are allocated local to that function. And I could get real technical here, but I won't. But all you have to know is whenever you have a local variable inside a function and you pass back the address of that local variable, then you can't count on it to be valid, and you should not count on it to be valid. That would be the source of subtle bugs where you add code later and it changes things and it's no longer valid. So let's go to another example and see how we might do it a different way that would work. So I've got some other code here. And there's basically two ways to do it. Here's one way. One way is for the caller, which is this guy here down in main, to allocate his own variable, meaning I want to receive the value in P. So this is a nice technique, because when you're using this particular method, you can not only pass a value to the function. If I wanted to pass a value to getPointer, I could do that, and also receive a value back in P if I wanted to. So let's look at what we're actually doing here. We're actually passing the address of P, this variable, to this function. And we designate that with the syntax of this function receives b, which is a pointer to a long, and it's a pointer specifically to this long variable right here. So when you assign a value to it through the pointer, what you're really doing is you're really reaching all the way back to the main and assigning 6 to this variable p. You're not assigning it to anything inside that function. So when getPointer executes and returns, p has the value that we look for, and it doesn't matter what calls go on in between. P will have that value, and you can print it, and this particular example would run and work. So that's one possibility. Another possibility is to allocate your own memory, okay? And what you do for that is, in this case, I've called it createPointer, and I'm saying to createPointer, I want to create something that's the size of a long, so it's going to be 4 bytes in size. Okay, so it comes in as size, and then this function is going to return a pointer. And I call it create pointer because I want it to be a reminder that the caller is responsible for releasing this memory that is allocated. So we have a local variable that says dim ps pointer, okay, and then we allocate storage. Just allocate storage in memory that stays around until you free it. It's not constrained by the limitations of the local function. As long as you pass that address, which is going to be in P, you just get the address of the storage. You don't get the storage, the data in it. You just get the address. So, and then we assign to that data at that address, we assign the value 6. Okay, and then so when we return P, we return that address. It comes back and is assigned to our local variable P, which is also a pointer. And then later we can print it and of course free it when we're all done. So these are two different ways where you can return a value from a called function using pointers. These are very valuable for all general programming, whether you're doing Objective-C, C, almost doesn't matter. I still use them in my Objective-C programming. And if you have a chance to look at FB2C code or the editor code, they're replete with use of pointers. You'll see pointers to FS specs, pointers to longs, pointers to all kinds of things passed to functions. That's one of the reasons that FB2C and FB5 generally runs pretty quickly and is pretty responsive. So I hope all that's helpful, and good luck. Ask the questions on the list. I'd be happy to help.